Hello, welcome to Global Youth Inspiration's first YouTube mathematics tutorial. I am your host today. I am your tutor rather. I am Mr. Mushabadi, and today I'm going to be taking you through Math-1110 tutorial sheet 1 from the University of Zambia. So yeah, if you do not have a copy of the tutorial sheet, we provided a link in the description where you can download it so that you can solve it at your own time, or you can download it right now and we can solve it together. So right now, let's get right into it. So let's start with question number 1. Okay, so I've decided not to use the whiteboard anymore because I felt like it was going to take up much of our time since we're solving an entire tutorial sheet. So instead of doing that, we're going to do the old-fashioned way, which is we're going to use plain papers. And today we're going to be using the ancient tutorial sheet. I call it ancient because it looks odd. Oh yeah, it is odd, but yeah. Anyway, so let's get right into it. So let's start with question number 1, which says list the elements of the following sets. List the elements of the following sets. So we're going to start with Roman numeral 1, which is set B. So set B says that x is even and x is also less than 19, and x is also a natural number. So all we're looking for are even numbers, which are natural numbers, which are also less than 19 and in this case 19 is not included because the less than here simply denotes that 19 is not part of the solution set. So in this case, it's just we're going to end up to a number that is less than 19 itself. So 19 won't be part of the solution set. So we can show that by doing this. So even numbers, which is 2 and 18 as our last element in the set. 19 is not included still. So we can go to the next one, which is set A. So in this case, set A says -2 is less than or equal to x, and x is also less than 3, and x is an integer. So in this case, all we're looking for are numbers that are starting from -2 itself. So in this case, -2 will be part of the solution set because it says less than or equal to. So when it says less than or equal to or greater than or equal to, which means that that particular number is part of the solution set. And when it says less than, that means that the number is not part of the solution set. Yeah, so in this case, we're just looking for numbers that are starting from -2 itself and less than 3. Okay, so to list set A, we're going to do this. So set A starts from -2 and 2. Yeah, yes, so in this case, and these are integers. Yeah, so we can go to set C. So set C says that x, or so we can say 4 plus x is equals to 3, and x is an integer as well. So in this case, we're looking for a number that we can add to 4, which is going to give us 3. Okay, so what we're going to do now is we're going to write down, so set C is equals to 4 plus x equals to 3. And what number can give us 3 if we were to add it to 4? So that the only number that's there is -1. So if we can add -1 to 4, which is going to be 3, so negative times positive is going to give us negative, so which is going to give us 4 minus 1 equals 3, which means that set C is equals to what? -1. All right, yeah, we can move on to the next one, which is Roman numeral 4, D. And here they're asking us to look for, or they're telling us x is a multiple of 3 and x is less than 10. So all we're looking for are multiples of 3. And what are multiples? Multiples are numbers that 3 can go into, without leaving a remainder. So which means 3 itself and the other numbers that it can go into, which it can go into without leaving a remainder. Yeah, so let's list them. So those elements in set D, okay, so the elements in set D that are multiples of 3 are 3 itself, 6, and 9. So the reason why it is ending up to 9 is because it says x is less than 10. So we're just going to end there. Yeah, so that's it for that question. Then 5 says set E has x squared, or x to the power 2, equals 1, and x is also what? A natural number. So remember, natural numbers are not in the negatives, so it's just the positive numbers in this case. So natural numbers are just positive numbers. So in this case, so we say set E is equals to what? X squared equals 1. So the only number that we can replace x for here, that was, which when we square it is going to give us 1, is 1 itself. So 1 squared is equals to 1. So which means that set E is equals to 1. And the reason why we could use -1, but in this case, we're looking for only natural numbers, and natural numbers are not negative. Yep. Okay, so we can go to question 6. Sorry for that. Question 6, Roman numeral 6, which says f. It's okay. Yeah. So set f, x squared is equals to 4, and x is also an integer. So f says x squared is equals to 4, and x is also an integer. So in this case, we're looking for numbers that we can substitute with x here to give us -4, and those numbers are -2 and 2 itself. So if we put -2 there, so because in this case, the reason why we have a negative in this case is because it's an integer, and integers are both negative and positive. So that's why we have a -2 there. So if we were to put -2 there, square it, it's going to give, the negatives are going to cancel and they're going to give us 4. And if we put 2 there, 2 is going to give us 4 automatically. So which means that set f is equals to -2, 2. And that's it for question 1A. Let's move on to the next one. Okay, so let's go straight to question 1B, which says let the universal set U equals x is less than 10, x is also a natural number or is a member of natural numbers, then A is equals to 1, 2, 3, 4, 5, B is equals to 4, 5, 6, 7, C is equals to 5, 6, 7, 8, 9, D is equals to x equals 2k plus 1, then E is equals to x equals 2k, and k is a member of natural numbers, and F is equals to 1, 5, 9. Okay, so the first question here, Roman numeral 1, says list down the sets U, D, and E, given that D and E are subsets of U, hence find the following. So in this case, we're going to start with Roman numeral 1, which is just listing down sets U, D, and E. Okay, so let's do that. Okay, so let me do this instead. So here we can see that it says x is equals to less than 10, and x is also a natural number. So to list down the elements of U, all we have to do is list down elements, natural numbers that are less than 10. So in this case, the numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can include 10 as part of the solution set. So in this case, we are only going to end up to 9. And so we're done with the universal set. We can go to set D. And set D says x is equals to 2k plus 1. X is equals to, so we can say 2k plus 1 is equals to x. So in order for us to find the elements of D, which is x, we need to substitute what? The elements of the universal set with k. The reason why we're doing this is because our question here says, given that D and E are subsets of U, which means that D and E are part of the universal set. So the only way to find the elements of D is if we substitute the elements in the universal set with this k here in order for us to find our x, which are the elements of set D. So this is pretty easy. So we can do 2 times 1, okay, plus 1 is equals to, so this is going to be what? 3. 2 times 1 plus 1, which is 3. Then 2 times 2 plus 1 is equals to 5. So if we continue substituting these elements with, with k, we're going to get odd numbers that are less than 10. So odd numbers, so you can try this at your own time, substitute everything, and you realize that we're going to get a pattern which is odd numbers. So which means that set D is equals to and 9, and those are the elements of our set D. Okay, so we move on to set E, and set E says, coming back here, set E says x is equals to 2k, and k is a natural number, is a member of natural numbers. So, okay, so 2k, we're going to do the same thing since E is also a subset of the universal set. All right, so to substitute, we're going to do 2 times 1 is equals to what? Is equals to 2. 2 times 2 is equals to 4. So if you can see what's happening here is we're getting another pattern, which is a pattern of even numbers. Okay, so in this case, if you can try them out at your own time, substitute them, you're going to get a series of even numbers. All right, so which means our set E is equals to 8, and the reason why ending up to 8 is because our universal set only goes up to 9. It can go up to 10 or beyond that, so we have to be in that range. So that's why we're ending up to 8. Same reason why we ended up to 9 with set D. All right, so since now we found the elements of we found the elements that we're missing of the various sets here, U, D, and E, we can go on to solve the following, which is Roman numeral 2, which says A intersection C union E. All right, so to make this quite easier for us, all we're going to do is we're going to list down set A. So on Roman numeral 2, so we're looking for A intersection C union E. So to make this easy for us, we're going to list down set A. So our set A here is 1, 2, 3, 4, 5. So our set A here is 1, 2, 3, 4, and 5. All right. Then we're going to list down our C union E set. All right. We're going to take this as a whole. So set C union E is going to be a combination of all the elements in set C and all the elements in set E. So we've already found our elements in set E, which are these here. So our elements in set C are these here, 5, 6, 7, 8, and 9. All right. So to put those together, all right, so we're going to have 2, 4, 5, 6, 7, 8, and 9. All right. And so now what we're looking for exactly here is A intersection C union E. All right. So what is common between the two sets here? So the common elements here are 2, right? We have 4 there, and we also have 5. So that's our answer, 2, 4, 5. That's our answer for this particular question. All right, so we found the elements of A intersection C union E. Then now they're asking us to find A union B intersection. Sorry, I went to the wrong question. So now they're asking us to find the elements of B minus A. B minus A. So, okay, so Roman numeral 3 says B minus A. Okay, so if we go back to the laws or the properties of sets, we know what B minus A is. For those that do not know, this simply means that we're looking for all the elements that are in B that are not in A. Okay, so all the elements in B that are not in A. So to simplify this, we have to simplify this solution here, or this equation here. So to simplify it, all we have to do is say B is B intersection A complement. All right, B intersection A complement. So this is our, this basically means this. It's just one and the same thing. So it's an intersection of the elements that are not in A with those that are in B. So which is the same as saying all the elements in B that are not in A. All right. So now we've been asked to find the elements in B that are in intersection, that are intersecting with the elements in A complement. All right. So in this case, what are the elements in set B? So we're going to list down the elements in set B. So here the elements in set B are 4, 5, 6, 7. 4, 5, 6, 7. All right. Then the elements in A complement, all right, are all the elements that are not in A. All right. So remember that our solution set here, our general solution set is the universal set, and the universal set only starts from 1 and ends up to what? And ends up to 9. So the A complement, okay, the elements in A are 1, 2, 3, 4, 5. So which means that A complement in this case is going to be A complement is going to be 6, is going to be 7, 8, and what? And 9. All right, good. So now to find the intersection between B intersection A complement, all we have to do is look at the common elements in this set. So B intersection A complement is equals to, we have 6 here, that's common, as well as 7. And that's our solution for this question. Alright, so now we're going to solve question 1b, Roman numeral 4, which says A intersection B minus B. Okay, so the solution, we're going to write the solution here. So A intersection B minus B, so we're going to say A intersection B intersection B complement. All right, so we're going to use the property of association to rearrange this. So we're going to say A intersection B complement. Okay, so from what we can see here, we can see that B intersection B complement is something that cannot happen because elements that are in B cannot intersect with the elements that are not in B. So there is nothing in common there. So which means that B intersection B complement is simply just an empty set. All right, so and we know that an empty set is a subset of set A, so which means that A intersection empty set is just an empty set. So in this case, we are not going to have any elements in this set because it's just an empty set when we simplify it. So we can move on to the next one. All right, so the next one here says F minus A intersection D complement. So F minus A intersection D complement. So we can write that down. F minus A intersection D complement. So just like we did in the previous question here, we're going to simplify this in a similar manner. So we're going to say F intersection A intersection D, okay, complement. All right, so what's going to happen next is that this complement is going to cancel out with that complement, so we're going to have F intersection A intersection D alone. So because this complement cancels out with that complement, so this is going to be our final solution in this case. So now we know that our set A here, so we need to find the elements for this particular set. So F is intersecting with A intersection D. So we're going to start with naming our set A. So remember our set A is a 1, 2, 3, 4, 5. So it's 1 to 5. So 1, 2, 3, 4, 5. And our set D, if you remember very well, our set D was a pattern of a series of odd numbers. So our set D was ending up to 9, so which was 3, 5, 7, 9. This was our set D. Okay, so now we need to find the intersection of A intersection D. So A intersection D is going to be, so what's common in the two sets? So we have 3 there. What else is common? We also have 5. So from A intersection D, we just have 3 and 5. So in our set F here, we're going to list down our set F as well. So our set F here is 1, 5, 9. Okay, so 1, 5, and 9 is our set F. So now we're going to find the the common elements in set F and in set A intersection D. So F intersection A intersection D is equals to 5, because that's the only element that's common in both sets. So our answer here is 5, and that's the end of this question. Okay, so now we can move on to the next question, which is 1C. And before we actually get into solving 1C, I just want us to make a correction here. So here it says the universal set is equals to X is a member of natural numbers, 1 is less than or equal to X, and X is less than or equal to 15. So I want us to cancel that 15 there and write 20 on top, so that the question can make sense. Because if we leave it at 15, sets like B, which only has elements from 1 to 20, will not be applicable in this question. So like we can change that to 20 and then we can move on with the question, right? Okay, now that we've made that correction, so let's start. So let u equals x is a member of natural numbers. 1 is less than or equal to x, and x is less than or equal to 20. Given that a is equals to x equals 2k plus 1 and x is less than 20, k is a member of natural numbers, and b is 1, 3, 8, 19, 20, and c is 1, 2, 6, 8, 9, 11, 15. So illustrate the information on the Venn diagram, hence find the following. Okay, so now in order for us to illustrate this information on the Venn diagram, we need to list down the universal set as well as set A in order for us to illustrate the entire information on a Venn diagram. So we can get right into that. So the universal set, here it says that 1 is less than or equal to x and x is less than or equal to 20. So which means we're just looking for natural numbers that start from 1 and 20. So 20. All right, so now we can move on to set A, which says x is equals to 2k plus 1 and x is less than 20. So which means 20 is not included in the solution set here. So for set A, we're going to have 2k plus 1, which is equals to x. All right. So since A is a subset of the universal set, we're going to substitute the elements in the universal set with k in order for us to get elements of A. So 2, 1 plus 1 is equals to 3. 2, 2 plus 1 is equals to 5. So if you notice here, there's a pattern of odd numbers. So if we keep on substituting these elements into A, we're going to get odd numbers. So you can do that at your own time. For now, I'm just going to list everything. So which is 3, 19, since it's less than 20. Okay. So now that we've listed down everything that needed to be listed down, we can now go on to illustrate the information on a Venn diagram. Okay, so we can draw the Venn diagram now, and this is the universal set. Okay, all right, so we're going to list down the information. We're going to illustrate the information in this. So to start adding on to this, so we need to know what's going to be in the intersections first, then we can go on to put everything in its in each element in its various set, and then we're going to add the universal set as well. Okay, so what's in the from here we can notice that what's in the intersection is 3. We have 3 there. We also have 19. We also have 11, 9, 15. We have 8, 1 and 8, and we also have 20 here. Now we have 5, 7, 13, and 17 in set A, and then we have 2 and 6 in set C. Then in the universal set we have 4, we have 10, we have 12, we have 14, we have 16, and we also have 18. All right, so we've illustrated the information on the Venn diagram. So now, since we've done that, we can go on to find the following. And so we can start with Roman numeral 1, which says A intersection A complement intersection B complement. And what is A complement intersection B complement? So we can refer to our Venn diagram. So A complement intersection intersection B complement is just everything that is outside A and B. So which leaves these elements right here, the 2 elements in C as well as the elements in the universal set. So we're just going to list those down. Okay, so A complement intersection B complement is equals to 2 and 18. Okay, so that's our final answer. And 18, yeah, that's our final answer. Okay, so we can move on to the next one, which says A union B intersection C. A union B intersection C. Okay, So what is common here? So all we're looking for is A union B, which is this, A and union B and intersection C. So what is common between A union B and intersection C? So those are the elements that we're going to be looking for now. Okay, so and those elements are 1, 8, 9, 11, 15. So those are our elements. So our answer is going to be 1, 8, 9, 11, 15. And we're done with Roman numeral 2. Okay, so we can move on to the next one, which is 3, which is A minus B union C. Okay, A minus B union C. So in order for us to find this one, we need to simplify it. And to simplify it, we're going to use the same methods that we used in the previous questions. So we're going to change this to the minus sign to intersection, which means this is going to be B union C complement. Okay, so now we're looking for B union C complement intersecting with A. So B union C complement, so this is B and this is union C, B union C, and everything that's outside here is the complement. And now we're looking for what's the complement is everything outside here, okay, outside B and C. So what's intersecting with set A? What elements are in the B union C complement that are intersecting with set A? And the only elements that are intersecting with set A from the B union C complement are the ones that are in A, so which is 5, 7, 13, and 17. Okay, so 5, 7, 13, and 17. All right, so our answer is going to be 5, 7, 13, and 17. And it ends there. So that's our final answer on that one. Sorry, that's our final answer. 5, 7, 13, and 17. Okay, so we can move on to the next question, which says A union B complement. So we can solve that there. Roman numeral 4. A union B complement. Okay, so all we're looking for is A in union with B complement, so which is just everything outside here. So that's our A union B complement, which is going to be equal to 2 and 18. So that's our A union B complement. All right, so that's our final answer. All right, so question 1D says list down all the subsets of each of the following. So we just have to list down the subsets of these sets right here. Okay, so 1 says A is equals to A. All right, so A is equals to A. So what are the subsets of A? So the subsets of A are, first we start with an empty set, then A, which is just 2. Okay, so 2, question 2 here says B is equals to A and B. All right, so it says B is equals to A comma B. All right, so to list down this, we're going to start with an empty set, then A alone, then B alone, and finally A and B. So we have 4 subsets of A, B. All right, then question 3 says C is equals to ABC. C is equals to ABC. So it's pretty easy. So ABC, we're going to start with an empty set, set A, set B, set C, and set A and B, set B and C, and set A and C. Finally, we have set A, B, and C. All right. So those are all the subsets. To count them all together, there should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have all our subsets there. So if you remember, at some point in high school, they taught us the easiest way to know the number of subsets that a set has is to use this formula where it says 2 to the power n. So n just stands for the number of elements in that particular set. So if we say 2 to the power, this is 1, so this is one element, 2 to the power 1, which is just equals to 2. If we say 2 to the power 3, this is going to give us what? 8. So that when we do this, so 8 is the number of subsets that we have. So 1, 2, 3, 4, 5, 6, 7, 8. So that's an easier way to also find out how many subsets that particular set has.